Greetings, dear colleagues. My name is Pavlo Radiuk, and I'm a PhD lecturer at Khmelnytskyi National University, Khmelnytskyi, Ukraine. On behalf of my co-authors, Olga Pavlova, PhD from Khmelnytskyi National University, and Hrypynska Nadiia, PhD from Khmelnytskyi National University as well, I'm eager to present our work titled An Ensemble Machine Learning Approach for Twitter Sentiment Analysis. The content of our work is as follows: motivation and state of the art, objective of the research, data preparation, feature extraction and representation, classification models, results and discussion, conclusion. In recent years, dozens of businesses have conducted numerous sentiment analysis on Twitter to determine the attitudes of their users to a product or analyze the market overall. It might be difficult for responsible staff to manually notice possible issues or even the crisis before it commences. Therefore, this study aims to investigate model natural language approaches that might facilitate sentiment analysis based on textual data from Twitter to efficiently assess and predict possible reputational failures of a business or social entity in real time. Intelligent analysis of microblogging using machine learning and deep learning methods and means has become highly relevant these days. At the same time, since the type of textual data and the conditions for short text messages on Twitter constantly evolve, there is an urgent need to develop new techniques for semantic analysis of textual data on this platform. In this work, we investigate several classification models and propose a new ensemble machine learning approach to categorize the polarity of tweets based on their semantics into positive and negative classes. The targeted data is presented in files with two columns: text messages and corresponding labels indicating the messages semantics. The training subset comprised tweet ID, semantics, and emoticons that facilitated predicting polarity. URLs and user mentions were ignored and dropped. The words within messages are meant as a mixture of words and phrases with errors, extra punctuation, and words with lots of repetitive letters. After preprocessing, the prepared training and test datasets comprised 100,000 and 10,000 text messages, respectively. Two types of features from the used datasets, namely unigrams and bigrams, were extracted from the prepared dataset. A regularity distribution of unigrams and bigrams was constructed, as you can see on the slide. A total of 50,000 unique words and 473,211 unique bigrams were extracted from the dataset as unigrams. The top 22 unigrams and bigrams were selected after that for the sentiment analysis. The extraction of features into unigrams and bigrams resulted in two feature vectors: sparse and dense vector representation. The choice of the vector representation depended on the type of approach. Several machine learning and deep learning techniques, namely random forest, gradient boosting random forest, support vector machine, multi-layer perceptron, recurrent neural network, and convolutional neural network, were implemented to categorize the sentiment expressions presented in a tweet. In this work, a long short-term memory was utilized. The maximum size of the input layer was set to 40, while the vocabulary size was set to 90,000 words. The temporal convolutions of 3 by 3 and a padding of 1 by 1 were applied to the convolutional architecture to process sequential data. In this work, several convolutional architectures with numbers of convolutions of 1, 2, 3, and 4 were explored. The maximum size of the input layer was set to 20, with a vocabulary of 70,000 words. A straightforward ensemble model based on previously mentioned approaches was constructed to improve the obtained classification results. We extracted a 600-dimensional dense feature vector from the penultimate layer of a 4-layer convolutional neural network. As such, an ensemble of 5 different models was prepared, and the results were used in the majority vote of predictions. The figure in the slide illustrates the proposed ensemble model. The initial data of 100,000 tweets was split into training and validation subset of 70% and 30% respectively. In addition, the sparse vector representation of tweets was applied to the random forest, gradient boosting support vector machine, and multi-layer perceptron, while the dense vector representation was applied to the recurrent and convolutional neural networks. Based on the experiments, both neural networks showed better classification performance than other classical machine learning techniques. The best recurrent model achieved an accuracy of 84.03%, and the best convolutional model reached 85.52% on the test dataset. The fine-tuned four-layer convolutional model obtained the best results with the support vector machine classifier of 85.52%, and the proposed ensemble model with the majority voting of 85.71%. It was discovered that the convolutional neural network model with the support vector machine classifier demonstrated generally better performance than a single convolutional network. At the same time, the ensemble method, based on the receiving the most votes according to the 5 based models predictions, reached the highest accuracy of 85.71%, surpassing the simple deep learning models by more than 0.19% and demonstrated its practical usefulness. Overall, this study aimed to address the issue of classifying emotional expressions based on small text, in essence, tweets extracted from Twitter. According to the computational results, the considered techniques could efficiently facilitate sentiment analysis of tweets by assessing and predicting possible business outcomes on Twitter in real time. It was also investigated that bigrams contributed to improving the classification accuracy and appearance in the sparse vector representation, recorded a better performance than regularity. The semantic analysis showed that tweets do not always have strictly positive or negative emotional expressions. Sometimes they may not have semantics at all, just be neutral. Further research will expand the number of categories of emotional expressions of semantics, for example, to classify moods from -3 to +3 or -2 to +2. In addition, a more detailed linguistic semantic study of tweets on various real-world issues will be conducted. I appreciate your attention, and I am pleased to answer all the following questions. Thank you.